Hi guys, welcome to lesson 10.2 part A, simplifying radicals. And this actually includes part of lesson 7.5 that we skipped to a couple months ago. So our objective for this lesson is that I can simplify radicals involving products and that I can rewrite expressions involving radicals and rational exponents. So what is a radical expression? It's an expression that contains a radical, such as 2 times the square root of 3 or the square root of x plus 3, anything that has any kind of radical or roots involved. A radical is simplified if all of the following are true. The radicand has no perfect square factors other than 1. The radicand contains no fractions, and that there are no radicals in the denominator of a fraction. So, there are 2 pieces that we need to know. We have the index and the radicand. The radicand is what's under the radical symbol. And the index is the degree of the root. So usually we've seen square roots where there is a symbol there, like in our 2 examples here. There's a symbol with nothing there, that's a square root. If there was a little 3 written there, it would be a cube root. 4 would be a 4th root, etc. Okay, so, and you can simplify radicals using multiplication and division properties of square roots. And the multiplication property of a square root says that if you have the square root of a, b, that is equal to the square root of a times the square root of b. Okay, so we can split our radicals up into various pieces. So, to simplify the square root of 72, what I want to do, first of all, it's not a perfect square, so I know I just can't take the square root of it. It'll be some irrational number. But I can simplify it a little bit. So what are my factors of 72? Well, it's even, so I divide by 2. So I get a 36 times 2. Okay? Well, what we're going to do is we're going to use this property that says the square root of 36 times 2 is going to be equal to the square root of 36 times the square root of 2. So we have the square root of 36 times the square root of 2. Well, the square root of 36 is something that I know, and that is just 6. And then we leave the square root of 2 there because that's as reduced as we can go. Okay? And that's our final answer, 6 times the square root of 2. Now we can always double check these radicals that don't involve any variables. We can say 6 times the square root of 2 is 8.48, etc. If we took the square root of 72, we get the exact same irrational decimal. Okay, so that's one way to check when you don't have any variables in your radicals. All right, square root of 125. That's easy to split up. I know that it's multiplied by 5, so I can have 25 and 5. So we are going to split that into 2 radicals. We have the square root of 25 times the square root of 5. Square root of 25 we know is 5, and it's the square root of 5. Okay. Letter C, it's an even number, 126, so I know I can divide it by 2. So I have the square root of, and 126 divided by 2 is 63. Okay, so we're going to split it into our 2 radicals. We have the square root of 63 times the square root of 2. Square root of 63 is 63 is, can't take the square root. So, but we can split it into 9 and 7, and we still have square root of 2. So this one we had to split into multiple times, just because right away I didn't recognize that I could divide that by 9. But you can still get there in the end. So we have square root of 9 times the square root of 7 times the square root of 2. Okay? So when we do that, square root of 9 is 3 Square root 7, square root 2, we can't take the square root of them. It's an irrational number, so we're just going to multiply them back together and leave it as the square root of 14. Okay, so 3 times the square root of 14. So we split into 2 terms, and then we had to split this one into 9 and 7, so it was eventually 3 radicals in order to get one that we can simplify. Okay, I want you guys to try letters D, E, and F, and then I'm going to walk through them. So letter D, square root of 98. Again, that's an even number, so I can divide it by 2, and I get the square root of 49 times 2. So that's the square root of 49 and the square root of 2. Square root of 49 is 7, square root of 2. That would be your final answer. 288, I can divide that by 2. So we start with a 144 times 2. Square root of 144, square root of 2. Square root of 144 is just 12, square root of 2. Letter F, 48. Well, I know that is 16 and 3. So I've got 16 times 3. So we split that. Square root of 16 times the square root of 3. Square root of 16 is obviously 4. 4 square root of 3. Okay. Moving on to our next section. Removing variable factors. So we're going to follow the same process. We're going to try to split it up into our factors that we can multiply by, and we are going to figure out ways to simplify them. So one of the things that I like to do, first we're going to start with the coefficient. So we have the square root of 54 is 9 times 6. So it really helps us to know our multiplication facts for these. Now, I always want to get my variable term so that it has an even exponent. So I'm going to subtract 1, and I'm going to say n to the 6th times n. Because n to the 6th times n would be n to the 7th. But now I have an even exponent that I can take a square root of. So again, we're going to use that property where we're multiplying radicals together and they all get mushed together under one radical symbol. We are going to split them apart. So we have the square root of 9 times the square root of 6 times the square root of n squared times the square root of n. Well, the square root of 9 is 3. Square root of 6 is just the square root of 6. The square root of n to the 6th power is n to the 3rd power, and we still have the square root of n. Okay. Letter B. We have negative m square root of 80m to the 9th. First, notice we've got that negative m out in front, so that's always going to remain there. So we're going to just start by writing negative m. And we have our radical. 80 can be broken up into 4 and 20. M to the 8th times m. Okay. Well, perfect square, but not a perfect square. Square root of, or splitting 20 up, we would have negative m times the square root of 4 times 4 times 5 m to the 8th m. Now, something I want to point out here, when we're taking square roots, essentially we're looking for pairs of factors that are inside, right? Because if we've got the square root of 16, 16 is 4 times 4, square root of 16 would be 4. So if we've got a pair of 4s right here, so we're going to bring one of them to the outside. So we have negative m times 4, and we've got 5, can't do anything with. M to the 8th we can take the square root of, and that'll be m to the 4th, and this m is still there. So we have 5m still under the radical. Okay, now let's just put it into our standard form in a proper order. Negative 4 times m to the 5th power, because there was the 1 out in front, times the square root of 5m. Okay. Letter C, the square root of 243x to the 5th. We rewrite that as the square root of 81 times 3x to the 4th times x. And when we do that, square root of 81 is 9. Square root of x to the 4th is x squared times the square root of 3x. 9x squared times the square root of 3x. Okay. Why don't you guys try letters D, E, and F on your own, and then I will go over them. All right. Now, letter D, 216, we can break that into 9 and 24. So we have 9 times 24 times y to the 6th times y. That would be our first split. But I'm pretty sure there's some perfect squares that are contained in that 24. So I'm going to rewrite that and break it into some factors. We have 9. 24 is 4 times 6. 9 times 4 times 6. And we still have y to the 6th and y. Well, that's a perfect square, that's a perfect square, and that's a perfect square. So square root of 3 is, or square root of 9 is 3. Square root of 4 is 2. Square root of y to the 6th is y to the 3rd. And we're left with 6y under the radical. Now we just need to simplify. 6y to the 3rd, square root of 6y. Okay. Letter E, we have 360 x to the 6th. Well, that can be square root of 36 times 10 x to the 6th. Square root of 36 is 6. Square root of 10 x to the 6th will be x to the 3rd power. 6x to the 3rd, square root of 10. Okay. Letter F. Letter F. 320 can be split into factors of 16 and 20. Y squared, y. Well, 20 can be broken up further, so we have the square root of 16 times 4 times 5, y squared, y. My perfect square factors, 16, 4, and y squared. So we get 4 times 2 times y, square root of 5y. And then we just simplify. 4 times 2 is 8y, square root of 5y. Okay. Now, finding higher roots, problem 7.5, number 1. So this is where we're dipping into those 7.5 lessons. We need to look at roots of larger numbers. So what are my factors of 27? Well, it's 3 times 9, and that's the square or cube root of 3 times 3 times 3. Now you'll notice here we have 3 3's, and we're taking the cube root. So we're going to take all 3 of them out, and we're just left with a 3. Okay, and we can do this on our calculator. We do the math button and go down to number 4, which is the cube root of 81. Sorry, that's the later. Cube root of 27, and we get 3. Okay. Now, 32, we're taking the 5th root of it. Well, I'm going to just start dividing by 2 a bunch of times, and when I do, I get 2 times 2 times 2 times 2 times 2. 5 2's there. So there are 5 2's, and I want to take out a group of 5. There's one group of 5 in there, so it's just going to be 2. Because 2 to the 5th power would be 32. The 5th root of 32 is 2. Okay? And again, we can test those in the calculator. Now, 108. Well, we can divide that up into 4 and 27, which can be broken up into 2 times 2 times 3 times 3 times 3. So essentially what we're going for is our prime factorization here. If we bring everything down to prime, we can see what groups of, in this case, it's going to be the third root. So if we're looking for groups of 3, there's 3 3's right there. So we bring 1 to the outside. There's one group of 3. One group of 3. Okay, so how many 2's? There's only 2 2's, so we can't take the cube root of 2 2's. So it's just going to be the cube root of 4 as the simplified version. Okay, and if we typed that into the calculator, we would get the same answer. If we did the cube root of 108, and if we typed in 3 times the cube root of 4, we get the exact same irrational number. Okay, I want you guys to try letters D, E, and F on your own. Okay, so the 4th root of 81. So we've got the 4th root of 81, which is 9 times 9, or 3 times 3 times 3 times 3, which is just going to be 3. We're looking for the 3rd root of 64. Well, that's 4 times 16, and 16 is 4 times 4. Well, 3rd root, I'm looking for groups of 3. There is one group of 3. Square root, or sorry, 4th root of 128 is, well, we break that up into a whole lot of 2's. We've got 2 times 2 times 2 times 2 times 2 times 2 times 2. Now we're going for the 4th root. So 1, 2, 3, 4 2's can come out of our radical. So the 4th root of that would be 4th root of 16 would be 2. 1, 2, 3 left, so I don't have enough to take out another root, so it's just going to stay underneath the radical. 2 times 2 times 2 is 8. Don't forget to include the index on it. Okay? All right. Moving on to problem 7.5, part 2, converting to radical form. We have a theorem that if the nth root of a is a real number and m and n are positive integers, then a to the 1 over n is equal to the nth root of a. And a to the m over n is equal to the nth root of a to the m power. All right, so we have a to the 5/6. So that's going to be the 6th root. The denominator is always our index. The numerator always stays with our variable. So it's just the 6th root of a to the 5th. Letter B. This is an important distinction here. The exponent is only being applied to the x. There's no parentheses there, so it's only being applied to what it's attached to, which is the x. So the 5 is just going to be chilling out front. Nothing happens to the 5. The exponent isn't touching it. Now, x to the 1/3 power is going to be the 3rd root of x. So if you were ever typing in square roots into your calculator, you could always put it into the 1/2 power and you would get it. Same answer. All right. So let's take a look at letter C. Now we do have parentheses. So we do have something that we need to deal with. So we've got the third root of what's inside. We've got 54y squared. And right now I just want to worry about converting it. I'm not worrying about whether or not 54 squared is the simplified form of that term. You know, there probably is a factor we could bring out, but I'm not looking for that right now. I just want this conversion. Okay. So you guys try letters D, E, and F on your own, and then I'm going to go over them. So letter D, we have x to the 4/3 power. So that's going to be the cubed root of x to the 4th power. We have for letter E, 27x to the 1/3 power. So that'll be the cube root of 27x. The whole thing goes underneath because it's in parentheses. Okay. And letter F, 54x to the 3/4. That'll be the 4th root of 5x to the 3rd power. Okay. Now, 7.5 number 3 is going the other way. We're going to exponential form. So to go to exponential form, we take whatever is the exponent on our variable, that's going to be our numerator, and whatever the index is, that's our denominator. So this is x to the 2/3 power. Letter B, we have 4y to the 5th, and we are taking, when there's nothing there, means we're taking the square root. So it's 4y to the 5/2 power. Okay. Letter C, 256x to the 8th to the 4th power. So we're going to have this in actually two different ways. So we're going to have 256 to the 1/4, x to the 8/4. Well, let's just try this and just see what we would get if we did, and actually I'll show you also how to do the 4th root of something. So if we want to do the 4th root, we type in 4, math, go down to number 5, you'll see it's an x with a radical. So this is saying take the 4th root of 256 and hit enter, and we'll get 4. And 8/4 is going to reduce to squared. So that would be 4x squared would be your answer. Okay. I want you guys to try D, E, and F, and then I will go over it. So, letter D, we have y to the 3rd, and we're taking the 4th root of it. So that's going to be y to the 3/4 power. 64 to the the cube root of 64. So we have 64 to the 1/4. Sorry, 1/3, and that would actually be 4. We've seen that already. And letter F, we're taking the 4th root of 128. So that is 128 to the 1/4 power. Okay, 128 to the 4th power. Okay. Now, moving on to the last page of our notes. Multiplying two radical expressions. So now we've got two radicals that we're multiplying together. I always start by writing them under, one thing you want to look for is, if you can, simplify. I see that this is the square root of 9a cubed. We can simplify. I'm going to show you two routes. So the first route I'm going to show you is to simplify radicals first. So 2a, nothing I can simplify inside of there. 9a cubed, there is something I can simplify there. So we have 2a, and we have square root of 9 is 3. We can bring out 1a, and we're left with the square root of a. Okay, so now we multiply. Our radicals are multiplied, so we get 3a out in front, and 2, and a times a is a squared. Well, the square root of a squared is a, so we have 3a squared times the square root of 2. And when you guys are watching this, it'll have already happened, but Wichita State was just upset by Marshall, so how many of your brackets just got busted? All right, so we've got letter B to take a look at. So this one, how about we approach it by multiplying? And one thing that you could do is you could just start listing out prime factors when we mash them together. So 6 is 2 times 3, and 18 is made up of 2 times 9. Remember what I said, when we're looking for square roots, we're looking for either pairs of prime factors or we're looking for things that we can take the square root of. So I have a pair of prime factors in 2's, and I can take the square root of 9. So I bring out one of those, one of the pairs of 2's, and the square root of 9 is 3. And what am I left with? The square root of 3. Now I just simplify what's out front. 2 times 3 is 18. Square root of 3. Okay. Letter C. This is one where I would want to multiply these together and see what I get. So 7 times 3. We always multiply any coefficients that are out in front first. So 7 times 3 is 21. And we have the square root of, multiply our coefficients inside. So 5 times 20 is 100. And we've got x to the 5th times x, which is just going to be x to the 6th power. So in this case, it was easier for us to multiply everything before we try to simplify. Square root of 100 is 10. Square root of x to the 6th is x to the 3rd. So when we simplify, it is 210x to the 3rd power. Okay. You guys, getting kind of repetitive, try D, E, and F, and then I'm going to go over it. So we've got the square root of 8y times 6y squared. So this is one where it's kind of a good way to do it is the prime factors. So I've got the square root of 2 times 4, so not quite prime factors. 2 times 4, and then I'm going to do my other coefficient. So we have 2 times 3 times y squared. So I have the square root of 4 that I can take, because that's a perfect square. I also have a pair of factors in there of 2's. So I bring out a 2. I bring out another 2 with the square root of 4. And I have y squared, so I can bring out a y. What am I left with? I'm left with 3 and y. So now I just simplify. 2 times 2 is 4y times the square root of 3y. Letter E, 4 times the square root of 6x cubed times square root of 21x to the 5th. Going with prime factors again, I have a 4 on the outside, and then we put everything under one radical. So 6 is 2 times 3. And 21 is 3 times 7. And x to the 5th times x to the 3rd is x to the 8th. So things that I can take roots of, I've got a pair of 3's. And there's a 2 and a 7. Can't take the square root of those. But I can take the square root of x to the 8th. So I have the 4 out front times a 3 times x to the 4th. And what's left is the square root of 14. And 4 times 3 is 12, x to the 4th, square root of 14. Okay. Last one. We've got 3 times 5 is 15. 12 is made up of 3 times 4 times 4 times z squared times z. So things I can take a square root of: 4, a 4, and a z squared. So I get 15 times 2 times 2 times z times the square root of 3z. Last thing, I just need to combine. 15 times 2 times 2 is 60. Z times the square root of 3z. Okay. Last part in this section is 7.5 part 4, which is using a radical expression. So you can estimate the metabolic rate of living organisms based on the body mass using Kleber's law. The formula R is equal to 73.3 times the fourth root of m cubed relates the metabolic rate measured, or R, measured in calories per day to body mass m measured in kilograms. What is the metabolic rate of a dog with a body mass of 18 kilograms? Okay. So let's plug it into the formula. R is equal to 73.3 times the fourth root of 18 cubed. Okay, so there's two ways we can do this on the calculator. One of them is I can type in 73.3 times, I'm going to do math 5, sorry, we'll do 4 math 5, and I want to put it in parentheses 18 cubed, and I get 640.56. calories per day. Now that's one way of typing it into the calculator. Another way, I mean, it gets a little cumbersome with the fourth root and the radical and all that. Another way would be to use that rational form where you use it as an exponent, and you type in 73.3 times, we're going to do 18 to the, in parentheses, 3/4 power. Get the exact same answer. Okay, so two different ways of doing it, whatever is your preference. Okay, we're going to use the same formula to find the metabolic rate of a dog with a mass of 35 kilograms. So R is equal to 73.3 times the fourth root of 35 cubed. When you type that into the calculator, you get 1,054.76 calories per day. Okay. All right, that's the end of our notes for today. Make sure you rate your level of understanding 1 to 4. Write down any questions or confusions that you may have from this lesson. I'm willing to bet there are quite a few. This is a tougher, these rational exponents are tougher topics, and there's going to be a lot of questions, so make sure you write them down. And make sure you're asking them in class so you can get the practice that you need. Lastly, write a summary of what rational exponents are and how to multiply them and how to deal with them, and that's going to be it. See you all in class.